Hey everybody. Today we're talking about regular expressions, which let you search and manipulate strings, basically character vectors, based on patterns rather than just exact matches. This is intended to be a pretty lightweight introduction for our users that just want to get things done and aren't so interested in all the nuts and bolts. So it's not intended to be comprehensive. Throughout this vid, I'm going to make use of three functions from the stringer package, which I talked about in my last vid. Link up top if you're interested. String subset is going to take all elements of a character vector that include certain substrings. String detect is going to give you back a logical vector to say whether or not you have matches. And string extract is going to actually pull out those substrings from each of the individual elements of that character vector. I'm also going to use the built-in vectors from the stringer package, sentences and fruit. In particular, I am just going to use the first 10 elements of the sentences vector. You can see things like a large size in stockings is hard to sell. Fruit consists of 80 different fruits, and so we'll be using these two throughout the vid. If all you're trying to do is match some letters or numbers, you don't need regular expressions at all. You can just match directly with something like string subset fruit comma quote berry. You can see we have 14 things that have the letters B-E-R-R-Y in this vector. Regular expressions come into play when we need to make more complicated matches. In particular, if we want to match certain characters, we won't be able to just do it literally. Those special characters are dot, slash, pipe, and the other ones that you see here. For instance, this dot that I've started with matches with any character, and that explains this output. Let's extract the dot from each element in the sentences vector. You'll see it's not actually pulling out any dot. Instead, it's pulling out just the first letter. String extract, by the way, pulls out the first match from each element in the vector, so the first match to any character in the sentences vector is always just the first letter. If we actually want to match the period that comes at the end of these sentences, we need to precede it with two slashes, like this. So string extract, sentences, comma, quote, slash, slash, dot. Now I'm matching a literal dot. So if you want to match any of these other characters, you're going to have to precede them with two slashes. To specify that a substring needs to come at the start of a string, we precede the substring with a caret, like what you're seeing here on line 44. So this is going to give us all the elements of the fruit vector that start with RE. And you can see there's just one of those. To specify that an element needs to come at the end of a string, you put the $ after the substring. So here on line 45, we're just going to get the fruits that end in ER. So notice that the order here is logical, but not necessarily consistent. We can specify multiple options for a character to be matched by enclosing the options within a bracket. So for instance, here on lines 53 and 54, I'm looking for all the sentences that have an N preceded by either an O or an E. So here are the vectors, or rather the elements of that character vector that meet one of those two conditions. And here are the actual parts of each of those sentences where the match is occurring. And you can see we have some ONs and some ENs. You can use ranges of letters and numbers if you like. So here, for instance, we are going to allow any letter from A to J inclusive followed by an O. And here are the actual pieces of those strings that have those matches, things like B, O, and HO. When you're inside of a bracket, you can use a caret to represent negation. So the caret is representing something different when it's inside a bracket versus when it's outside. So here on line 67, I'm going to take the pieces of these strings that have an O preceded by something that's not a letter from A to J. In particular, notice that the sixth element of the resulting vector has a space before the O. So it's literally negating the letters A through J, not saying just the letters from K through Z. It's possible to specify entire classes of characters For instance, a slash and then a lowercase d will match any digit, and a slash and a lowercase w will match any word character, which is from A to Z, caps or lowercase, 0 to 9, or an underscore. If you capitalize the D or the W, that'll match anything except digits and word characters, respectively. There are lots of other classes available, and if you look at the help file for regex in R, you'll get a full list of those. One caution here, however, is that these are going to be a little bit specific to where you're at and what language you're using. There are many, many different alphabets in this world. So if you want to get into the weeds of dealing with all of that, you're kind of in the wrong place. Sorry, I'm not going to go into it here. Now, this is a good place to mention that slash that we're looking at has a special role in Quarto. Quarto isn't going to render this slash D that I typed in this previous paragraph correctly because it thinks the slash has special meaning. Let me just render this and let's take a look at it. All right, now let's just scan down to where we were. Oh, there we go. Okay, so you can see that where I typed quote slash D quote, it didn't render the way that we might have thought it was going to based on the QMD document. Instead, we just got a quote. And the reason for that is because when I typed this quote slash D quote, Quarto saw this slash and then thought the things that were coming after it were supposed to be some sort of special instruction. So if we want to actually render the slash D, we have to let Quarto know that that's not the case, and the escape character that we're going to use there is another slash. So depending on your perspective, the use of slash as an escape character in both Quarto and regular expressions is either really consistent or really confusing. So it might be both of those things. If you want to render a slash in Quarto, you'll need to type actually two of them, and you can see how that worked over here. Let's match some white space. We use //s for a space, //t for tab, //n for a new line. So for instance, to match E space B, we use the regular expression E//SB. So the string subset that I'm showing here on line 85 is going to pull out all elements of the sentences vector that have that pattern. For instance, the very first element in the vector has canoe followed by the word slid, which matches that pattern. If you want to specify that a letter is occurring more than once, you don't necessarily have to type it over and over again. You can use curly braces to indicate how many times in a row a character has to appear. So for instance, here on line 92, I'm saying there have to be two E's in a row. For instance, the very first element of the sentences vector includes the word sheet. If you want to specify that you need at least one occurrence, but possibly more, use a plus. So SHE plus T is going to also pull out that same one because the letters SHE and T never appear in a row here, but SHEET do. This would also identify SHEET, etc. You can indicate that a character is optional using a question mark, so TH question mark E will allow for TE as well as THE. So you can see it pulled out all of the words the, as well as all the instances of just TE. Finally, the asterisk indicates that a character is optional, but that it could occur more than once. So for instance, on line 111, we're going to extract all of the places in the sentences vector where we have SH possibly followed by an E. And you can see we have one SH and one SH followed by two E's. Now, in each of these cases, notice that the symbols come after the character that they refer to, unlike the slash that came before. So there's definitely some typographical things that you have to watch out for when you're dealing with regular expressions, just in terms of the order that you put things. If you need to do an OR statement in regular expressions, use the pipe, that vertical bar. By default, the expressions on either side of that vertical bar are going to be grouped by default. And so that explains the behavior we get from line 121. String subset sentences, comma, chicken, vertical bar, hog. That's going to find all elements of the sentences vector that include either the word chicken or hog. And there we go, we can see it. You can still group using parentheses. Here they might be optional, but in some cases they may become important. For instance, here in line 127, I'm going to subset the sentences vector so that I have either the word chicken or hog followed by an S. And you can see this time we only have one of the two sentences that we had before because chicken did not have an S at the end, while hog did. One last comment as I wrap up here, and that is that as I wrote this video, I decided to prioritize the appearance of this Quarta document that we're looking at here rather than the HTML file. And that means that I typed things like that, where'd it go, that /D, even though I knew it wouldn't render right, because I knew I'd be teaching from this document. That means if you're looking at the HTML file that I made here, for instance, on my website, equitableequations.com, or on my GitHub, for instance, it won't look quite right. Not only just in that one place that I pointed out, but in several others as well. So just bear that in mind.